are having this session that is of paper 5 S1. And today you people had a great paper, and that paper was P1. So P1 happened on 6th of October, and S1, inshallah, will be happening on 8th of October. So today is Monday. That is when we are having this session, and 8th October is Wednesday. Now, people ask this question, what is this session all about? The session is all about a review of S1 papers, and I'm focusing on 2025. That is the most recent year. So now let's focus our energy instead of writing comments in the YouTube section. Just focus over here, and we'll be selecting few questions, and those questions are selected over here, as you can see. So let's get started. This is the first variant, 5-1. And let me look at which questions have I selected. So let me first focus on this one. Now it says, find the number of different arrangements of the 8 letters of the word kangaroo in which 2 A's are together and 2 O's are not together. So now over here, what we see is that the word kangaroo, Kangaroo, that is kangaroo, and the 2 A's are together, that is the box concept. Put them in a box. And then it says that what is not together. So what is not together is that the 2 O's are not together. So now let me just do one thing, and then I think it's all good. The do not disturb for the notification. So now what we do is that put them in a box. Consider this box as one unit. 1, 2, 3, 4, 5. That is 5 items. So that is 5 factorial for this. But before that, there are 6 gaps over here. And these 2 O's will fit in these 2 gaps. So that is 6P2. But one other thing is that since these 2 O's are identical, therefore we divide by 2 factorial. So 6P2 over 2 factorial, that's for the O's. For these green ones, that is 5 factorial. What is happening inside the box? Technically nothing. Why? Because there are 2 alphabets, and they can arrange in 2 factorial ways. Divide by 2 factorial for the 2 A's. So that is one permutation part that comes a lot of times. So you should be well versed in it. Not only have we focused on the concept of together, we have focused on the concept of separated. That is the space concept. Now, all of a sudden, the mood changes. And it's no more about permutation or combination. It is about probability. It's about probability distribution. Now, which kind of probability distribution is this? It says a fair 8-sided dice has face label KANGAROO. The dice is rolled repeatedly. There are no fixed number of trials. So let me write over here. There are no fixed number of trials. So if there are no fixed number of trials, therefore this is definitely not binomial. Yes, there is a probability of success. The probability is about obtaining A. How many A's do we see? We see 2 A's out of 8. So 2 over 8 is 1 over 4. That is the probability of success. But this is not binomial. This is geometric because of the statement word repeatedly. And that is what we are focusing on. So now repeatedly, that thing is there. Now it says X is the number of A's. Find the probability fewer than 6 rolls are required to obtain A. So success is getting A. Probability of success 1/4. Probability of failure 3/4. X follows a geometric distribution of 1/4. And probability X lesser than 6. That becomes lesser than or equal to 5. So calculate the probability for 1, 2, 3, 4, 5. Add it all up, or apply the shortcut. That is probability X lesser than or equal to N, 1 minus Q raised to power of N. So that is how this thing is done. It's preferable that you write answer in fractions because fractions are exact. But if you want to write in decimals, then take care of accuracy. Final answer, 3 significant figures. So now this thing is there. Find the probability that the second A is obtained on the sixth roll of the dice. So the second A is obtained. That means there should be a first A among the first five rolls. So now the working is this. Out of the first five roll of the dice, you should be obtaining one A. And then separately, you should be obtaining a sixth one as an A. So now this sixth one is an A. That is the second A. So that is 1/4. That is geometric. It's a combo. It's a combination of geometric and binomial. Now, out of the first five, you can have any one A. Order does not make a difference. That is why this is binomial. This kind of classic questions have appeared in the year 2023, 2024. Now, someone can ask this question, sir, you have it all sorted out. Why is it all solved? Because on my channel, that is Mathematics with Shahab Yaqub, I have already solved all these variants. The same way that I solved all four P1 variants, I have solved all the four variants. Now, yes, there are four variants, 51, 52, 53, 55. There is no 54, there is directly 55. So if you want to check out the whole detailed solution of every single question, every single variant of 2025 S1, you can check it out. So, of course, after this session, because now you have 2 days to do a lot of things. So even one day is more than enough. So just apply that knowledge over there. So now this is this thing that is 1/4 over here. This is 5C1, success raised to power of 1, failure raised to power of 4. Now, when I apply these two, when I multiply these two, that is 1/4 raised to power of 2. This is 5C1 is 5, 3/4 raised to power of 4. I would again prefer fractions because, yes, you have a calculator. So why worry about it? And as far as the accuracy and all these things are concerned, let me show you the working, the examiner report also, but after a short while. So now this question is done and dusted. So now the first one is done. Let me remove it. Now the next one, that is about stem plot and mean and standard deviation. Now both these things are part of representation of data, descriptive statistics. That's another name for it. Now it says last Sunday, team of runners took part in a charity event. The time taken in seconds to run 50 meters was recorded correct to 1 decimal place. The times recorded for 11 runners from each of the two teams, gulls and herons. So I have labeled the gulls with a green color. I have labeled the herons with a pinkish color. So now these are the two teams. Now, whenever you have this data, the first checklist is whenever you have data related to a table or something, or maybe raw data, and we are talking about a stem and leaf diagram or stem plot, or maybe we are talking about a box and leaf, box and whisker plot, or simply known as box plot. So always make sure about the order in which the data is arranged. Now let's have a look. 7.9, 8.2, 8.3, 8.6, 8.6. This is neatly arranged, but this one is not. So 9.5, 9.9, 8.5, 8.1, 10.8, 8.3. This is not. So you need to arrange this thing in order. That's the first thing. Now they are asking this, draw back-to-back stem and leaf diagram to represent this info with gulls on the left-hand side. So now you have to follow the instruction. You can never argue with the examiner. If they say write on the left, you should write on the left. Naturally, herons comes on the right. Now, this is pretty basic stuff. I won't go into the detail. What I want to focus on is this thing, that when you are having this thing, make sure you write the key. Now, it's your choice whether you want to write two separate keys representing the data, or one single key is also more than enough. So you can have a one single key just like this. For example, I have written over here 7/9. So over here 7/9, but we start from the stem and go towards the leaf. That is 9.7 seconds. So let me just correct myself. I made a small error over here. For the gulls, that is 7.9 means 9.7 seconds. And the key for the herons, let's say this is 9.2, 9/2, that means 9.2 seconds. So I have done this correction over here. Or you can have a single key. and you should write out what it means. Some people, they just write the key, but they forget to write what it means. So you should write it. Now, another very basic stuff that people ask, the examiner asks, that is about median interquartile range of the times of the runners from the gulls. So now this is about how many total values were there. There were 11 values. So you take this 11, you divide by 2, that is 5.5, round it up, that is the sixth value, that is the median value, that is the value in the middle. So T6, the median value that is in the middle, and 5 values are lesser than this, 5 values are greater than this. Out of these 5, pick the middle one, that is the third value. Out of these 5, pick the middle one, that is the third value. And then you write 1, 2, 3, 4, 5, 6. So 8/8, that is 8.8, that's the median. Out of the 5 small one, 3/8, which means 8.3, that's the lower quartile. Out of the 5 bigger ones, pick up the middle one, 8/9, that is 9.8, that is the upper quartile. Upper quartile minus lower quartile. Let me also write it like this. Interquartile range is upper quartile minus lower quartile. That comes out to be this. Q1 is the symbol that we use for lower quartile. Q2 is the symbol that we use for median. Q3 is the symbol that we use for upper quartile. And that is how this is calculated. Now, in the same question, now another twist comes in. What is this twist all about? This twist is about that is mean and standard deviation. So now it says two other teams, the red ones and the blue ones. The red ones are the Eagles, the blue ones are the Swifts. So the data is given 20 runners from Eagles, 30 runners from the Swift are denoted by X and Y. So 20 from Eagles, 30 from Swift are denoted by X and Y respectively. Now it says sigma X is 175 and the mean of Y is 8.4. So now this is the data that's given. Now someone has asked me to share the link. So of course they can come to the channel and double check the link, but let me still share it with them. So now there is the session thing. Okay, got it. So now it says sigma X is 175, N is 20, N is 30, Y bar is this. Now the formula for mean, that is X bar is sigma X over N, or Y bar, let me remove it, Y bar is sigma Y over N. So now over here, nothing needs to be done, but over here, simple working needs to be done. So you find summation of Y, the sum of scores of Y, that is this thing. Now they're asking by all the 50 runners. So I have W as the symbol for X and Y for the whole group of 50 runners. So sigma W is basically sigma X plus sigma Y. So I take 175, I take 252, I add it up. Number total, that is 50. Therefore, W bar is this divided by this. It so happens that this 3 significant figure value is actually an exact value. Let's move on. Now it says it is given that sigma X square is this much. It is also known that the standard deviation of the times taken by all 50 runners is 1.38 seconds. Find the value of sigma Y square. So now over here, I'll just wait for Azan. Okay, people. So now let's continue. It says that it is also given, let me just remove this thing. It is also given that sigma X square is this much. It is also known that the standard deviation of the times taken by all 50 runners is 1.38 seconds. Find the value of sigma Y square. Now, first of all, let's start the working from here. So sigma square for the group, that is sigma W square over number of people in the whole group minus W bar square. So now simply make sigma W square the subject. So first of all, this negative will go to the other side and become positive. That is the first thing. That is this positive, this negative becoming positive. Secondly, this NW, it goes to the other side and multiplies. And hence we find sigma w square by doing this basic calculation. So sigma w square is coming out to be this. This is just some extra stuff that I explained that time. I've already explained it over here. Now sigma w square is simply sigma x square plus sigma y square. This is calculated. This was given. Hence, you make sigma y square the subject of the equation. So now this thing is done. Let me just remove this. So this thing is done. And let's focus on this one. Now, this question over here, it says in a group of 20 musicians, and this is a very classic question. Now, keep in mind, people, that what we are doing right now, this is variant 5.1 of May, June 2025. And this question number 5, it's a very classic question. And also remember that you need to watch variant 55. There's another question, of course, of permutation combination. And that is very similar to this one. And that is another difficult question. So let's see if we get a chance to go over that. Otherwise, you can always go back to the channel and watch that particular video. Well, coming back to this, it says in a group of 20 musicians, there are 9 guitarists, 6 pianists, and 5 drummers. 6 musicians are selected from these 20. So 9 plus 6 is 15, 15 plus 5 is 20 to perform at a concert. Now, part A. Find the number of different ways in which the 6 musicians can be selected. That means it is combination. If there must be at least 3 guitarists, at most 2 pianists, exactly 1 drummer. Now, the very first thing that we need to do is that we have to decide that first of all, drummer is 1. So this is kind of fixed. So don't worry about that. Now worry about the guitarist and the pianist. So now guitarist and pianist, basically these two should add up to 5. At least 3, at most 2. That means 3 could become 4, 4 could become 5. 2 could become 1, 1 could become 0, because 3 plus 2 is 5, 4 plus 1 is 5, 5 plus 0 is 5, and this 1, 1, 1, that is the 6th one. So you need to work very, very comfortably. So now over here, it says that from 9 select 3, from 6 select 2, from 5 select 1. That is exactly what's written over here. So now over here, what do we have? From 9 we select 3, and then from 6 we select 2, and then from 5 we select 1. Similarly over here, 5C1, 5C1, that is fixed. And then this is 9C4, and this is 6C1. This is again 9C5. This is 6C0. Write down all the different options, 6300, 3780, 630. Add it all up and you get this answer. So that is how this particular question is done. That is for 4 marks. So now over here, I have done this question. And let me first show you the blank page so that you can have a good look at it. And then I'll do an easy version and then the real question. So that is how much I'm focusing on this. Now it says the 3 bands will be selected from the original group of 20. Each band will consist of 3 guitarists, 1 pianist, 1 drummer. So let me write over here that is 3 guitarists and 1 pianist and 1 drummer. So these are the 3 that you need. Actually 5 people, but 3, 1, 1, but 3 categories. No musician can be playing in more than 1 band. Now, this is the first condition that makes this question difficult. The first band selected will play at a concert in France. So the first band will play in France. The second band will play in Italy. The third band, will play in Spain. So now the locations are fixed. So third band in Spain, and then second band in Italy, and then first band, they will play in France. Now, find the number of different ways in which the 3 bands can be selected. Of course, they have given lesser marks. That's not the issue. they have given us lesser marks because it's kind of difficult, because there is location involved. No musician can be in more than one band, and so on. So, what I have done is that I have first modified the question. So, I have done this. Let me remove this thing. And so you can easily watch what I'll be doing. That is the easy version. Let me just remove this. Okay. So now over here, just focus on this. First of all, what I'm doing is this. Instead of 3 bands, I'm selecting 2 bands. So that is the first thing that I'm doing. So now I'm selecting 2 bands from the original group of whatever the number is. So that is 5. I have reduced this. Each band will consist of 3 guitarists and 2 pianists. I'm just removing this. No musician can play in more than one band. That is all good. No issue with that. The first band will play in France. So the first band will be playing in France. First band, they will play in France. And since there are only 2 bands, the second band will be playing in Italy. And now what I'm doing is that let me grab my black marker and I'm just removing this thing. So this is my version of this question, the easy version. Now let's first understand this so that it's easier for you to understand the original question. Now let's say there are 3 guitarists. I need one. So now it is 1 and 1. So there are, I need how many? 2 bands selected. Each band will consist of 3 guitarists, 2 pianists. So no, I'm changing this. Where is my eraser? There it is. There it is. So now over here, I'll be needing 1 guitarist, I'll be needing 1 pianist, and 3 guitarists out of 1 guitarist out of 3, and 1 pianist out of 2 pianists. So that is the data that's written over here. 3 guitarists, I need 1, 2 pianists, I need 1. Now, first of all, band 1 will play in France. 3C1 into 2C1. 3C1, 2C1, that is easy. But since no musician can be in more than one band, so what should I do? 2C1. Now 3 reduces to 2 and 2 reduces to 1. So this comes out to be 2. So now this thing will be happening and simultaneously this thing will be happening. So 6 into 2 is 12. And then what have I done over here? That I have done is this thing that made you understand, trying to make you understand with exact things also. So let the 3 guitarists, their names be A, B, and C, and the 2 pianists, their names are X and Y. So what are the different possibilities that are there? So now locations are fixed. In France, let's say A is there in France, and from here, X is there. So if A and X are chosen, so this is gone. We are left with B and C and only Y. So 2 options are there, BY, CY, BY, CY. Got the idea? Now let me choose A with Y. Let me choose A with Y. B and C are left with X. So 2 options, BX, CX. The same thing can be done with BX and BY, CX and CY. These are the final outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 outcomes. So AX, BY is one outcome. AX, CY is the other outcome. AY, BX, AY, CX, BX, AY, BX, CY, BY, AX, BY, CX, CX, AY, CX, BY, CY, AX, CY, CX. So there are 12 options. So that further solidifies, consolidates this fact. Now, what about the original version? This is the original version. Out of 9 guitarists, we need 3. Out of 6 pianists, we need 1. Out of 5 drummers, we need 1. Again, there are 3 countries involved, France, Italy, and Spain. So now, first of all, 9C3. This is for this thing, 9C3. And this 9C3 becomes 6C3 because 9 minus 3 is 6. 6C3 becomes 3C3. Think like that. 6C1 becomes 5C1 becomes 4C1. And 5C1 becomes 4C1 becomes 3C1. France and Italy and Spain. So this will happen and this will happen and this will happen. So each answer written down separately, multiplied together. That's a big exact answer. Do not round off. So now this thing is done and dusted. So let me go to the favorites and let me remove this. So now let me first take you to the examiner report for this one. So now examiner reports um, is a very, very good way of understanding what exactly do the examiner need. So now over here, the first one, let's highlight it, probability and starts S1. And this key message is for which paper? This is for May, June 2025 variant, the first one, which is known as 5-1, because this is paper 5. My bad. This is 5-5. So I should open the right one and hold for a second. Let me choose this color. Let me choose this. Let me choose this. And let me go to the favorites. So therefore, this is, I think that's the one. This is 5-1. Okay. So now this 5-1. This is May, June 2025, variant 5-1. And this is probability and starts 150. Now look at this working. I'll be underlining it. Candidates need to be aware that working and method must be shown clearly to support the answers. There is no compromise on this. Working and method must be shown clearly to support the answers. And then it says values calculated must be verified by including the mathematical operation and processes that produce them. That it further means show all the working. Successful solution require both clear communication and accuracy. That means if you are clearly communicating it, if you are showing all the mathematical operation, if you are showing all the processes, if you are showing the method and the working clearly, and accuracy is taken care of, then that solution will be successful. The necessary intermediate steps should be included, especially when proving a given result. Show that the answer is this. So show all the working. Now, as far as accuracy is concerned, there is no angles in S1. So it's only about one level of accuracy. And what is the level of accuracy? That level of accuracy is work in 4 significant figures at least, so that final answer is given correct to 3 significant figure unless otherwise stated. And the next thing is fractions are beautiful, fractions are exact, fractions are supreme. So whenever there is a possibility, work in fractions. So fractions should be our first priority wherever, whenever possible. Also, when we talk about NCR, when we talk about NPR, over here, exact values, because there is no rounding off. So exact values should be there. Fractions can also be used in, should also be used in probability. Maybe you are dividing 2 probabilities, final answer can come out as a fraction. So just take care of all these important details. All good, all clear? Now, let's continue reading. So now it further says that where a diagram is requested, candidates would be well advised to be precise in its execution. It should be clearly and accurately drawn and appropriately labeled. Let's say we are drawing a cumulative frequency curve. Let's say we are drawing a histogram. So then the x-axis, what goes on the x-axis, what goes on the y-axis, that should be clearly labeled. Maybe we are drawing a stem plot, then a key is necessary. Maybe we are drawing a box plot, then a scale is a must. And yes, it is well advised that all the diagrams should be drawn in pencil, because then you have a chance of erasing it without getting all panicky and anxious and things like that. The examiner will even accept it in pen, but why take the risk? Now, something about accuracy, which I talked about earlier. Let's focus on this. Candidates should state only non-exact answers correct to three significant figures. Exact answers should be stated exactly, such as this thing. Exact answer should be stated exactly. And then it says to justify a final answer, correct to 3SF, working values correct to at least four significant figures should be used in candidates' calculation throughout. Already written over here, at least four significant figures. You can work in 5SF also. That is what the word at least means. There is no requirement for fractions to be converted to decimals. Why? Because fractions are exact, fractions are beautiful, fractions are supreme. So fractions, that is the highest priority wherever, whenever possible. So of course, they should not be changed to lowly decimals. Keep that in mind. When considering scenarios, what kind of scenarios? When considering scenarios in combinatorial questions, permutation and combination, that's combinatorics, or outcomes in probability question, it is important to ensure that all the required values, including zeros, are concerned. Basically, it's giving you a reference to discrete random variable. Okay, so now this thing is all done and dusted. Let's move on. So that was the first one. Let me just open the second variant and let me choose the second variant from here. So now that is the second variant, the 5-2. And there are some questions which are highlighted. So now the first one is over here. Let's have a look. And I'm just looking at something else. Okay. I think this is the one. This is also geometric. We did a similar questions like this, but it makes sense, especially the third part. Now it says a fair six-sided die with faces labeled 1, 2, 3, 4, 5, 6 is thrown repeatedly until and until a 3 is obtained. Geometric probability distribution. The number of throws taken is denoted by random variable x. Find the probability that x is equals to 8. So now over here, the focus is on the number 3. So let me highlight this number that is over here, the number 3. So probability of getting a 3, that is 1 out of 6. So this is 1 out of 6. That's a probability of success. So we should always state the distribution. Probability x is equals to 8. Success should be the last thing. And there should be 7 failures before that. So failures, 4, 5, 6, 7, and then a success. Multiply the probability by itself 7 times, multiplied by probability of success. Exact, and this is decimals. Probability x is less than 9. We talked about it before in the previous question. Probability x less than 9 does not exist. Less than or equal to n exists 1 minus q raised to power of n. 1 minus 5 over 6 raised to power of n. Sometimes they can even ask this, probability x greater than n. Over here, the greater inequality is used, that is q raised to power of n. Part C, look in 2024, there are similar questions to this one. Find the probability that the 3 is obtained for a second time before the 6th row. Now, how is this question different from the one that we just did? That was on the 6th row. Two things on the 6th row. This is second time before the 6th row. That means before the 6th rows could be a 5 throws, 4 throws, 3 throws, 2 throws. 1 throw won't work because we want 3 twice. So now the last one is geometric. And out of the first throw, I need success. Again, I could have written it directly 1 over 6, but I preferred to write it as a binomial. 1C, 1, success raised to power of 1, failure raised to power of 0. This is for the first row, and the last row has to be success. Similarly, out of 3, there is 1 success, and out of these 2, I need 1 success. Last one is a success. Out of 4, 3 are left. Out of 3, I need 1 success. Out of 5, last one is a success. From the first 4, I need 1 success. So write down all the possibilities and add it up. This, in my view, is one of the most trickiest question of geometric probability distribution. So most trickiest, cunning question of geometric probability distribution. Okay, so now this thing is done. What is the next one? So now I think I have on the wrong thing. Hold for a second. Let me just double check one thing. This is variant 2.2, and I think I missed to the variant 5.3. No issue. So let's just discuss 5.3. Not an issue. So 5.3 is there. And let me choose one other question. Let's say this one. Now, this one is also a nice question that I'm choosing. So instead of 5.2, I have by mistake moved to 5.3. Doesn't make a difference. All the videos are there on my channel. Now it says, bag A contains 6 red marbles, 5 blue marbles, 1 green marble. Total is 12. That is bag A. Bag B contains 5 red, 3 blue, 5 plus 3. That is 8. But there is a catch. What is the catch? A marble is chosen at random from bag A and placed in bag B. That means initially there are 12 over here. And of course, that is what we will use for probability. But after 1 is transferred, now 8 plus 1 is 9. That is the second denominator. That is the denominator for the second set of tree diagrams. A marble is now chosen at random from bag B. Draw a tree diagram. So these kind of questions do come a lot. Now, what is the logic over here? The logic is the colors are red, blue, and green, 6, 5, 1. So red, blue, green, 6 over 12, 5 over 12, 1 over 12. Do not reduce the fractions. Now over here, there is 5 and 3. So first write 5, 3, then write 5, 3, then write 5, 3. Over here, the denominator is now increased to 9. And the denominator is increased to 9. That is obvious. Now, after red, when we are getting a red, the red increases by 1. After blue, getting another blue, the blue increases by 1. And since you are getting a green and there was no green over here, you were only having 2 colors. Now you are adding a new thing, 1 over 9. That is the new thing over here. Have a good look at this. So new green branch, bag B. So this was also a nice type of a question. Rest of the thing is simple, nothing special. Now it says find the probability both marbles chosen are of the same color. It could be red, red, it could be blue, blue, it could be green, green. Add it all up and this is the answer. Find the probability marble chosen from bag A is blue, given that the marble chosen from bag B is blue. So now sometimes they use the previous part for conditional probability. How do we know it's conditional probability? Because the word given is there. It could also be used, the word if can also come if it's talking about future tense. Given, that is about past. So now, given marble chosen from bag B is blue. That means it could be red blue, it could be blue blue, it could be green blue. That is this much. And they are saying marble from bag A is blue. Bag B is already blue. So that means this is bag A, this is bag B, this is A, this is B, this is A, this is B. What goes at the top? Marble chosen from bag A is blue. That is the thing. Bag B is already blue. So 5 into 4 is 20. So this is 20 at the top. This is 57 at the bottom. So no, 57 is not for this one. My bad. This is 41 over 108. This is 20 over 108. So 20 over 108 divided by 41 over 108. That comes out to be 20 over 41. That is the answer for this particular part. So now this thing is done. Okay, let's move on. Let me look at something that is slightly different. Yes, a lot of people they ask about this thing. Now, this is from the variant 55. So I'm just choosing variants here and there, okay? Because I want to give you the variety for the review session. There should be binomial, geometric, stem plot, box plot, mean, standard deviation, probability, permutation, combination, and I've given you all the variety so far. So now it's time that we can talk about normal distribution. Let's talk about this normal distribution first. That is the normal approximation, and then another question of normal distribution. So now over here, let's have a look. It says in a certain large school, on average, 2 pupils in 5 have music lesson. A random sample of 80 pupils from the school is chosen. Use an approximation, find the probability fewer than 27 people have music lesson. Now, first of all, there is only one approximation that we study, and that is normal approximation to binomial. That means the question is of binomial, it will become normal because the numbers are large. There are 80, that is the number of trials. N is 80. So let me write over here. N is 80. Probability of success is 2 in 5, that is 2/5. Probability of failure, that is 3/5. So you have to calculate three things. The first thing that you need to calculate, let me remove this color right now, that is NP. So we calculate NP, that comes out to be 32. We calculate NPQ, that comes out to be 19.2. So NP is mean, NPQ is variance. And you should always justify. Justify what? Justify the approximation. Since NP is greater than 5, and we also calculate NQ, which has no meaning, but it's used as justification. NQ is greater than 5. So NP is greater than 5, NQ is greater than 5. Therefore, X follows a normal distribution. We write the mean over here, the variance over here. That is the first thing. Now look at this. They are giving us 5 marks and they have given us so little space. That is why it's all jumbled up over here. Now, then they are saying less than 27. Less than 27, what does it mean? Less than 27, you cannot use this value because this came from a discrete probability distribution. Binomial is discrete. So you have to use the boundaries, either 26.5 or 27.5. The same concept as in O-level maths, IGCSE. That is lower bound, upper bound. We are going to the left. We are going to the left. This blue line is including 27. A red line is not including 27. Since it's not included, that is why we choose 26.5. That is how I explain it. Standardize, get the Z value. Z lesser than a negative value is the same thing as Z greater than a positive value. That's a normal distribution curve. You need this thing. Read the probability from this one and subtract. Read the probability from this one and subtract, and that is your answer, correct to 3 significant figures. Now over here, the next one, a random sample of 10 pupils from the school is now chosen. Find the probability no more than 2. No more than 2 means at most 2. Have music lesson, probability of success. Probability of success is music lesson, that is 2/5. And the number of trials is 10. That goes over here. This is a simple binomial. No approximation. That is what I mean by the word simple binomial. Probability y is less than or equal to 2. So basically, you have to calculate the probability of 2 and 1 and 0. 10C0, success raised to power of 0, failure raised to power of 10. 10C1, success raised to power of 1, failure raised to power of 9. 10C2, success raised to power of 2, failure raised to power of 8. We calculate this, we calculate this, we calculate this, add it all up. This is the answer that you get. So now this thing is also done. Let me look at a normal question, which is slightly different. Yes, this is the one that I was looking for. This is from variant 52. Now, let me first add a page and let's focus on this page. I want you to read the question first and then make up your mind. Once you make up your mind, then I'll tell you the solution. Now it says kestrels, a bird whose adult wingspans are normally distributed with mean 74.8 and standard deviation 3.2. A random sample of 120 adult kestrels is selected. How many of these 120 would you expect to have a wingspan between 72.4 and 76.3? That is one thing. And let's focus on the first one. So now over here, normal distribution, the mean and variance is given. And when we talk about binomial, so that is the formula for expectation. Right now, we are talking about normal distribution. X follows a normal distribution with such and such. Probability X lies between these two values, that is 76.3, 72.4. Standardize each one. How do we standardize? Subtract the mean, divide by standard deviation. Subtract the mean, divide by standard deviation. Keep in mind, in the bracket, we write variance, but we divide by SD. SD is square root of variance. Z lies between these two values. Rule number 7, according to the way that I have taught, ignore the negative sign. Read the table for both. Phi means read the table. Phi means read the table. Use the Z value to calculate probability. That is what phi of Z means. This is what you're getting from the table. This is what you're getting from the table. Add the probabilities, subtract 1, leave the answer as it is. Now it's asking for expectation because the number of trials is given. It's just a ratio thing. So multiply it with 120, you get an answer, and they are birds, people, apples, oranges. You need answer in integer. Both are acceptable. Round down, round up, both are acceptable. So any which one you should write. Don't write both of them. That's your choice. So now it says the masses of adult kestrels are normally distributed with such and such. It is known that 20% of the adult kestrels have mass greater than 0.202. 20% have masses greater than this. Probability X less than this much is 0.20. 28% have masses less than 0.185. 20% have masses, 28% have masses lesser than this. Now, what do we do? First of all, over here, in order to do the back solving, that means using the probability to find the Z value, make sure of one thing, ensure one thing, that the probability is at least 50%. 50% is 0.5. This is 0.20. That means to the right of this value, 0.202 is 20%, to the left is 80%. That is exactly what I've written. The next thing, lesser than 0.185 is 28%. Greater than 0.185 is 72%. So that's the first thing that you should do. Then you should standardize, subtract mu, divide by sigma. For 80%, the corresponding Z value is 0.842, lesser sign, Z value positive. Focus over here. 72%, the Z value is 0.583, greater sign, negative value. This is standardization. Now what do? We take this thing, we equate it to this. We take this thing, we equate it to this. Now over here, what do? We take this thing, we equate it to this. We take this thing, we equate it to this. Don't forget the negative sign. You are getting two equations. You solve simultaneously and you get the answer. I think it's on the next page. Over here. Solve simultaneously, you get mu, you get sigma. Correct to three significant figures. And now that was this thing. This is all done and dusted. So let me just remove this page over here. And I think we have done enough of revision. Let me go over this thing. Now, this particular one, the second variant, let me focus on this. So this is May, June 2025, variant 5.2. Let me read from this examiner report also, because the wisdom that is over here, that needs to be implied, because otherwise don't expect a great result. Examiner reports, they are the most important thing. So ER, the examiner's report, what they focus on, what they observe, what they talk about the common mistakes, what they talk about the successful scripts. So examiner's report, that is the gateway to getting your A star overall in A2 and is in your AS level. So this is your gateway. Now, again, let me underline it. So let me grab this. Candidates should be aware of the need to communicate their method clearly. We talked about it last time also. Simply stating values often does not provide sufficient evidence of the calculation undertaken, especially when there are errors earlier in the solution. The use of algebra to communicate processes is anticipated at this level and enables candidates to review their method effectively and is an essential tool when showing given statements are true. In simple English, what it means is that show all working. Whatever I have shown, that is show all working. As simple as this. When errors are corrected, candidates are well advised to cross through and replace the term. It is extremely difficult to interpret accurate terms that are overwritten. Keep that in mind. Now, let's move on. What else are they saying? There should be a clear understanding of how significant works for decimal values less than 1. It is important that candidates realize the need to work to at least 4 significant figures throughout to justify a 3 significant figure value. Many candidates rounded prematurely in normal approximation questions, which produce inaccurate values from the tables and lost accuracy in the solution. There are no half marks. You lose accuracy, you lose 1 mark. The paper, complete paper is just about 50 marks. So you don't have any margin of losing mark. It is an inefficient use of time to convert an exact fractional value to an inexact decimal equivalent. Some people, they just have a fear of fractions. I don't know why. Maybe they're not taught the proper way, or maybe they think that decimals are supreme, decimals are exact. Not all decimals are exact, but definitely all fractions are exact. There is no requirement for the probabilities to be stated as decimals. That means that if it's coming out to be a fraction, write it as fraction. The interpretation of a success criteria is an essential skill for this component. Candidates would be well advised to include this within their preparation. That means whatever that you're seeing at the board, at the screen right now, that is all good, all important. Now, let me just focus on the general comments also. That is based on the questions. Although many well-structured responses were seen, some candidates made it difficult to follow their thinking within the solution by not using the response space in a clear manner. People think that teachers focus a lot on clarity. I mean, it's of no use. Who will care? They do care, as you can read it over here. The best solutions often included some simple notation to clarify the process that was being used. The use of simple sketches and diagrams can help to clarify both the context and the information provided. These were often seen in successful solutions. Candidates should be aware that the axes should be labeled with both the variable and the units. Yes, when we talk about graph, what are we talking about? Are we talking about frequency density, cumulative frequency? What are the units that are using? Sufficient time seems to have been available for candidates to complete all the work they were able to, although some candidates may not have managed their time effectively. A few candidates did not appear well for some topics, and now these are particular things. So I think that is all about it from my side. So we are all done with this session, and good luck for the S1. As I've told you before, all the variants of 2025 S1, they are on my channel, 51, 52, 53, 55. Try them out. Try 2025 paper. Make summary sheets. Do your level best. And inshallah, you'll be do amazing. Take care, everyone.